Hello everyone, my name is Katarzyna Wojdalska, and today I want to share with you my knowledge about the digital ecology. And to be more precise, I want to talk about the methods of how you can mitigate the carbon footprint of websites. So let's jump right into the topic, and first things first, what even is digital ecology? It is a field of study about the interdependence of digital systems and the natural environment. So, long story short, it is a branch of ecology that promotes green practices to make digital systems more sustainable. So, it's not about taking a step back, it's not banning you from using the internet. It's just about introducing some more sustainable, greener behaviors and routines. You might now wonder, how does it even work? How does the internet emit CO2? Let me answer that question. It all starts with data collection. So we have to think about servers, about data centers, and about the cloud. And data centers, you might think, it's just a building with one server or a few. But the truth is that they are enormous facilities which have to be powered up and cooled down 24 hours, 7 days per week. Next, data transferring and power lines. So it all is happening via the telecom infrastructure, which also has to be powered up all the time. And last but not least, end devices. Fun fact, in 2020, the energy that was needed for charging our smartphones overtook the energy needed for charging our PCs or laptops. And I'm not even mentioning about the energy and the emissions that are being generated during the manufacturing process and all the resources that are being used. So how important is this issue really? So the ICT industry is responsible for 4% of all greenhouse gases. So this is more or less 1.5 of global CO2 emissions. So it's quite important. And just if we go back and think about the cloud, so actually by storing 100 zettabytes, and we will store this much by 2025, we'll be emitting 200 billion tons of CO2 every year. So what can we do about it? We can actually do quite a lot, and by making insignificant changes, we can make a really significant impact. So what can you do if you don't program your websites? What can you do as a normal, typical person? So let's start by telling you a little bit about the emails. So first, you could just start by deleting your emails. Storing a single email for the whole year on your mailbox generates more or less 19 grams of CO2, and an average user has almost 10,000 emails in their mailbox. On the other hand, for example, if we send an email, we generate 4 grams of CO2. So think about maybe using some other messaging tools like Slack or the old-fashioned message, so SMS. And instead of these 9 grams, for example, you would go lower to 1.8 grams in case of an SMS. Then spam. So in 2020, almost 50% of our emails were spam. So this is quite a large number. And if we think that every day there are more than 340 billion emails being sent, then the scale of your spam is quite large. So just try to unsubscribe to some website, to some newsletters that you don't read anymore. And the size of emails is also important. So for example, if at the end of your message is your profile picture, your logo of the company, you could just delete it if it's unnecessary. Or if you want to send a file to multiple people and it's another file that you send them and another one, maybe try using a link. Maybe just add the file to your drive and just share the link. Next, browsing. So there are some alternatives to Google that you could use. So for example, there are more sustainable web search engines like Ecology or Lilo, or the more ethical DuckDuckGo. Try also closing tabs because I don't know if you knew, but the tabs which are still open, they remain connected with the servers. So you would think that nothing is happening, but the truth is that they are still emitting some CO2. And if you remember the addresses that you want to Google, just write them directly in your tab. Try also using some bookmarks or rethink your keywords. And from time to time, it's really good to just take a look at your old social media platforms and erasing some media. You could just download your pictures on an external hard drive and store your pictures just like that. And if we think about the devices, then changing smartphones or computers less often is also a more sustainable routine. So if you consider replacement every 6th year instead of every 4th of your smartphones or of your computer, then you suddenly emit 190 kilo of CO2 emissions less. So this isn't such a huge difference in time, but when it comes to the emissions, it really matters. You could also delete some mobile apps that you don't use, or even now you can disable some mobile notifications that bug you and that you don't read anymore. And from time to time, you could also unplug your router for the whole night. But the main topic of today's speech, because there are many, many different things that we could do, but what I really want to talk about today are websites. And I don't know if you knew, but every day 250,000 of new web pages are being published. And one view of a website, of a typical web page that would be viewed, let's say 10,000 monthly, would generate 1.8 gram of CO2. And this would sum up to 216 kilograms of CO2 annually. This number can be compared to driving 900 kilometers by a gasoline car. And the truth is that these emissions are not just this. This is not the total number of all calls. These calls can be really calculated here, so it's like really difficult to find a real number. So this is the basic number, but the total emission number is even larger than that. And you might now wonder, do you know how much your website produces? So how much it emits CO2? You can quite easily check it. There are multiple tools that you can find online, multiple carbon calculators for your website. But there is one I could recommend you. It's called Website Carbon Calculator. And by just adding your web page URL here, you could just click calculate, and then you would learn how much CO2 does your website by every view emit. You could also learn from these calculators what are some actions that you could immediately take. I can strongly recommend the tool. It was created by Tom Greenwood. He also is an author of the Sustainable Web Design book, and he's very frank about the formula that they use for calculating the emissions. And the formula that they used, and also that I am using in my team with the tool that we developed, is as follows. So we have to consider a few factors. For example, the data transfer of an average visit. So if we think about the data transfer of the first visit, it would stand for 25% of all emissions. And this would be the energy of the website. But also we have to think about the returning users, as some data was already cached. And this would stand to 75% of all visits. And this number then would be equal to 2% of the energy of the website. And then the energy of the website is the website size, which is multiplied by the end user traffic. And the end user traffic here is 0.81 kilowatt hour per gigabyte. Next, we would have to calculate the emissions of CO2 per one visit. And this would be the data transfer of an average visit multiplied by energy emissions. And the energy emissions are more or less 442 grams per kilowatt hour. This is the global average, but if you want to be more precise, you can just try Googling this number for your local country. And then if we sum it up, so the emissions of CO2 per one visit would be 75% multiplied by the website size plus 25% multiplied by 2% by website size. And this would be then multiplied by the end user traffic and by the energy emissions. So how can we create more sustainable websites? There are multiple methods that you could use, and today I'm going to talk about some of them. So first, for example, the programming language. I assume that most of you use JavaScript as your programming language, or TypeScript, which is not that good as JavaScript, but it's also relatively good. But for example, if you would like to add some Ruby, Python, and Perl code pieces, that would be not that sustainable. These languages are actually very energy consuming. Next, libraries. So here you can see a table with a few very popular libraries like Moment.js, Lodash, jQuery, SuperAgent, Axios, but there are also other libraries like Needle, GoDrequest. And you can see in the table the corresponding sizes and the corresponding emissions to these libraries. And for example, Moment.js, which weighs almost 4.3 megabytes, emits almost 5 grams of CO2. And here the question that you should ask yourself is, do I really need the functions that these libraries give me? Do I really need those libraries? And sometimes you don't. Maybe plain JavaScript is good enough, or maybe the simple built-in fetch just would be good enough to solve the issue that you're having. So just think about using plain JavaScript, or maybe introduce some lighter libraries. You should also consider the number of calls to external APIs, and you should think about reducing the number of the calls. It's important to consider caching of data, and as I already mentioned, just introducing plain JavaScript or lighter libraries. When it comes to resources, there are 3 most important resources you should consider: images, videos, and formats. When it comes to images, SVG and WebPy are the best formats that you could use. SVG is the vector format, and WebPy, if you didn't hear, it's a very, relatively new. It comes from 2010. It's a relatively new format, and it's highly compressed. And here you can see an exemplary image and its corresponding format files, file formats and file sizes and CO2 emissions. So for example, in case of SVG, the file size is almost 130 kilobytes and the CO2 emissions are almost 0.3 grams. And if you would then compare it with, let's say, PNG, then you could already see that the file size is huge. We talk about 2000 kilobytes, and CO2 emissions equal to almost 605 grams of CO2. So the change is really large, and if you just think about changing the file size, then it doesn't seem to be such a large change, such an impactful action. Then videos. The sibling format to WebPy is called WebM. It's also a very highly compressed format. And then when it comes to fonts, there are 2 things that I would like to mention about. So first, of course, it's much better to use system fonts than those which are hosted online. But if you can't find a good-looking system font, just try downloading a font that you would usually find which is somewhere online, and then just use it locally. So host it locally instead of hosting it online. And then when it comes to formats of fonts, the very popular format is called TTF, but some newer, some more compacted formats are WOFF or WOFF2. And here you can see a table which shows the dependencies. So for example, the size of TTF of Arial. So here we can see 1 gram of CO2 emissions, and WOFF already reduces this number by half. And then WOFFF gives us 0.43 grams of CO2 being emitted. So almost 60% less than in case of TTF. And in case of, for example, Monster Red, the WOFF2 format gives us a 70% of reduction of emissions for this fund. Then it's also really important to think about the color choice. So if you can't, for example, create a darker website, it's very good if you could enable a dark mode option for your users. But if we just think about your OLED screens, it's of course much worse to use a white background or some bluish colors on your website. It's better to use green, red, or black on your website. Then hosting. So if we think about hosting providers, let's always keep in mind the power usage effectiveness, so PUE. This is basically the number of energy which is needed to power up your data center. And the data center should ideally run on renewable energy. There are different types of renewable energy. Obviously, solar energy, wind energy. Some of the hosting providers use some more unique renewable energy sources. Like, for example, on Iceland, you could find this green host, which uses magma heat. But then your hosting provider could also be planting trees, or it can have some more eco-friendly, some more sustainable policies, like the green employee behavior policy. And if you don't know if your host provider uses a renewable energy source, or it has implemented any green behavior policy, then just try asking them, because maybe they aren't just promoting it, but they are actually doing something in this field as well. And if you don't know really where to find a hosting provider, then just try Googling the Green Web Foundation. And they have a long list of different eco-friendly hosting providers, both in Europe and in the US. And you can find there a few options. So, for example, here I listed some hosting providers from Finland, Lithuania, Germany, or the UK. Next, user data collection. Basically, if you don't need to collect the data, then just don't. And here you can see an example of a website called USA Today. And after they introduced the GDPR policies, the page was loading 90% faster. So that was actually a huge change because of less data collection. And why you should be doing all these? So first, of course, you mitigate the carbon footprint, and thus you can save some electrical energy. If you decrease the weight of your website, you can also decrease the loading time of it. And the loading time is quite crucial for your users. I guess that you've heard that for them it's really important, and the faster the website loads, the more likely they are to visit it once more. So for 53% of all users, they can be lost if the website would load longer than in 3 seconds. And if the website loads faster, then also the SEO is much better, and this is all what we want. Together with a few friends, I've been working on a tool called EchoLink, and this is a tool from the Lint family. I guess that you might have heard about S-Lint. So it's a linter, and it proposes possible code improvements to mitigate the carbon footprint of websites and makes them basically more sustainable. Of course, there are other tools that you could use. So, for example, you could just read the Sustainable Web Design written by Tom Greenwood. It collects all the information. You could use, for example, Google Lighthouse for improving your SEO, or you could analyze your website by using a website carbon calculator. But this tool acts before the problem occurs. So already when you would code your website, or if you want to do some changes on your website, you open it up in your terminal, and you just open it up, you run it, and you can introduce the changes already. So it would show you these code improvements, some comments that would show you as well the CO2 reductions that are the result of implementing a change like that. And the tool has two smaller tools in it. So it has EchoLink, which basically works as S-Lint, and EchoLink Style, which works as StyleLint. And EchoLink Style is for CSS and CSS-like languages. So this is the main difference. And here's the list of features that we already did, or that we are planning to implement. So, for example, we work on heavy libraries. We say that, for example, you could use a lighter one, or just use plain JavaScript. You can validate your format with this EchoLink, with this linter. You can also check the font source. You can work with images, with video formats. It also will be checking the number of videos and images, video autoplay, lazy loading. This one is quite interesting because, as you might already expect, if a user doesn't scroll down through the whole website, not all resources will be loaded. So, for example, if the user doesn't want to see an image, then the image will not be downloaded, let's say. So this also doesn't require so much data caching, and thus the total number of emissions gets down. Then we also have color control, dark mode control, CO2 module. So this would show you what are the corresponding savings in emissions. And we are working on Angular, React, and IDEA plugins. So you might remember that in the beginning of the presentation, I told you that every day there are 250,000 new websites being published. And this equals to 54 million kilograms of CO2 every year, which is being emitted. This can be compared to driving 220 million kilometers by a gasoline car. And we calculated that in theory you could reduce by using this liter emissions of a single website by 88%. So from these 220 million kilometers, we could just drive 26 million kilometers by a gasoline car. So the difference is quite enormous. And how to get started? So just download EchoLink and EchoLink style with their recommended configurations. Just initiate it in your console, and then just run it, and yeah, use it. If you are interested in joining our team, if you would like to maybe commit a feature or two, it is an open source tool, so it is completely free, and we are creating right now a community of different developers who could help us, who would help to scale the tool, and everybody is welcome to contribute. Here you can see the list of references, and this is my LinkedIn profile. If you would like to connect with me, if you would like to discuss more about sustainable website design, feel free to reach out to me. And thank you so much for your attendance. It was really great to talk to you. I hope that you've learned a thing or two. And yeah, if you would like to reach out, or if you would just like to leave a story for us on GitHub, thank you so much. Here are the contact details. And yeah, enjoy the conference. Thank you.